IRT Saint Exupéry seeks to optimize electrically powered systems to increase the performance and reliability of electric vehicles, clearly the future of transportation. In a more electric aircraft, the main objective is to replace pneumatic, hydraulic, and mechanical energy entirely by electrical energy. This energy will provide many advantages, notably less weight and energy consumption. It also results in reduced nitrogen oxides and carbon dioxide emissions and lower maintenance costs. Embedded electrical technologies will be omnipresent, providing the energy needed for aircraft control, air conditioning, engine startup, fuel circulation, and passenger comfort. Power density of these technologies will be increased significantly to become competitive. Transportation industries also face major challenges, such as equipment reliability, performance, weight, and cost. Together with our academic partners, we help industrials enhance these electrical technologies through R&D projects. The more electrical aircraft domain is divided into three main competence centers to optimize the electromechanical chain and convert electrical energy into mechanical energy. The Competence Center for Power Technologies and Integration focuses on increasing electrical system power density and reducing the weight of all components by working on 3D power module integration, converter architecture, and motor iron losses. To achieve global optimization, we study the interaction between different electromechanical chain components, leveraging research projects to propose the most efficient solution from an electromagnetic, partial discharge, or thermal management perspective. Projects are supported by highly skilled engineers in power electronics, motors, electromagnetic compatibility, thermal technologies, and optimization. We develop prototypes to validate our studies and test them with flexible and advanced platforms, including a highly accurate motor test bench, a 2D hysteresis graph, and an EMC chamber with a high-voltage DC power supply. Because of voltage increase, as well as the introduction of new electronic semiconductors, such as wide bandgap semiconductors, electrical systems are confronted with new or exacerbated physical phenomena, including electric arcs, partial discharges, and space charges. These phenomena impact the reliability of electrical systems, in particular insulation material aging. Projects driven by this competence center are supported by engineers who are highly qualified in partial discharge, arc phenomena, motors, and insulation materials. Dielectrics, Conductors, and Plasmas Competence Center seeks to master those phenomena in all dedicated applications by developing virtual and real-world platforms for characterization and proposing pre-designed tools and qualification procedures. We validate our studies and test them on flexible and advanced platforms for partial discharge pressure, thermal control, and electric arcs. Suppliers in aeronautics, space, and automotive industries are faced with strong economic competition, increasingly using commercial off-the-shelf components to reduce costs. However, those components are generally developed within short cycles, which is not compatible with operating lifetime guarantees required by space, aeronautics, and automotive equipment. Aging or second sourcing frequently obliges suppliers to invest in requalifying their equipment. Our Components Modeling and Reliability Competence Center seeks to understand failure mechanisms and predict the reliability of COTS components developed for other applications, such as the automotive. We also perform reliability studies at the board and equipment levels. Projects led by this competence center also develop electromagnetic compatibility models, compliant with the IEC standards to reduce requalification costs in case of obsolescence. Projects are supported by highly skilled engineers for reliability calculations, electromagnetic compatibility, electronic components, radiation, electronic assembly durability, batteries, cells, and stack modeling. IRT Saint Exupéry leverages the platforms of its academic partners, Laplace and IMS laboratories, to characterize and model battery cells and fuel stacks. We also prepare hybrid propulsion technologies through high-powered equipment. Because of the power level, voltage needs to be increased significantly. By helping our industrial partners, we prepare the integration of high-voltage electrical systems in the aircraft. IRT Saint Exupéry projects work on the better understanding of the impact of high voltage on electrical components. We develop design tools and qualification procedures and offer our platform to support theoretical studies and validate simulations.